Thursday, the 8th of October, Algebra 1 SWA students will be able to solve multi-step inequalities. So we did one-step inequalities last time. We did the addition, subtraction, multiplication, division, okay? We said a lot of this is actually very similar to what we do for equations, okay? But there were a couple key differences, like when we had to flip the inequality, whether or not we multiplied or divided by a negative number on both sides, or if we were changing around the order. Multi-step inequalities are going to involve more than one operation, much like multi-step equations that we did. We had to both add and subtract and then multiply or divide. So they're solved by undoing the operations the same way you would solve a multi-step equation. We're going to solve them the same way, and we're really just going to have the same special rules that we did last class, okay? So if I were to solve this inequality, 13 minus 11x is greater than 79, we're going to solve it the same way we would do an equation. So what would I do first here? Ellie? Get rid of the 13 by doing subtraction like Raquel said. So we're going to subtract 13 here. 13 minus 13 is 0. Negative 11x is going to stay as negative, is greater than 66. We have negative 11x is greater than 66. Now, does this turn into one of them that we had last class? Yeah, I think it does. So we divide by negative 11. X compared to negative 6. What do we have to do with our inequality symbol? Flip it because we divided both sides by a negative. So we have x is less than negative 6. So the variable is by itself. So now we can graph it and put it in our set notation.
Do we have to graph it like for every single time that we do it?
Yes. Yep. Yes. So the numbers I'm going to put on here, I'm going to put negative 7, negative 6, negative 5. Does that make sense?
Yes.
Okay. What kind of circle am I doing? Open. And where at?
This way. The left.
Okay.
We're going to the left.
And we are going to go to the left, starting at negative 6. Okay. So it's saying, hey, any numbers less than negative 6, but not including negative 6. Now for my set notation, how was that one? How was that bracket? Or that brace?
It's a little long. Just let me draw them.
I was trying really hard. Okay.
It looks really
Okay. X is x such that x is less than negative 6. So I'll take the advice to just scribble here. Okay. No.
Yeah, because you can't tell the number.
looking better. Looking better.
Oh, that was pretty good. That was pretty good. Okay. Okay, so x such that x is less than negative 6. Questions on this first one? All right, number 2, a over 6 minus 5 is greater than or equal to 2. I want you guys to try this one. When you have it or have questions, raise your hand. Okay. Number 2, since we're undoing these, we're solving for a variable, we have to go the opposite order, okay? So instead of doing PEMDAS, we're doing SADMEP the best that we can. Okay, there are a couple exceptions to when we can that we've talked about, but we're doing SADMEP here, okay? So our first step is going to be to do what? Okay, we're going to undo our subtraction by adding 5. Negative 5 plus 5 is 0. So a over 6 is greater than or equal to 7. Now what are we going to do? Brady? Yeah, multiply by 6, or a 6 over 1 if we prefer. So 6 is reduced, and now a is greater than or equal to 7. So if we make our graph here... Oh, wait. Oh my goodness, I forgot to multiply by 7, didn't I? What a is greater than or equal to what? 42. Thank you. Mr. Costle had a brain fart. I thought it smelled bad in here, okay? Get it? Brain fart smelled bad? Okay. Thank you. It's the pinnacle of humor. What? The pinnacle of humor, like the peak of humor. That's as funny as it gets right there, okay? So what kind of circle do I have?
A closed.
Okay, it's closed circle at 42. What direction does this arrow go?
Right.
To the right, because these are numbers greater than 42. So then our set notation. That was a bad one.
Is it okay if I just like squiggle lines?
Okay. Hey, how was that one?
That was pretty good.
Okay, thank you. Okay. A such that a is greater than or equal to 42. Okay. Yo, I'm feeling good about these now. All right. Okay, I'm going to give myself a slap on the back. Okay. All right. Questions on that one, guys? Give me a thumbs up if you're feeling good. Thumbs down if you're not. Okay, are these pretty darn similar to our multi-step equations? Yeah. How we solve them is almost the same, right?
I don't get how like the difference.
Yeah.
The only difference is that when you multiply by negatives, you divide by negatives, you have to square.
Hey, did everyone hear what Jaden said? Okay, he said the only difference between multi-step equations and multi-step inequalities is when you multiply or divide both sides by a negative number, you have to flip the sign. That's our only difference. Okay.
You're so smart.
I know, right?
Good. Hey, that was a great way to word that. Haven, thanks for putting that phone away. I appreciate it.
Actually, a prodigy.
Okay.
I
I knew it.
compliment anybody that
Okay.
takes a second.
So on a problem like number 3, what would we do? Distribute, right? Okay, let's do 3 together, okay? So 2 times k is 2k, not like the game, but you know. 2 times 1 is 2.
Yes.
Is greater than or equal to. What's going to be on my right-hand side here? Go ahead, Jack.
4k,
Yep.
Go Jack.
minus 8.
Nailed it. 4k minus 8. So 2k plus 2 is greater than or equal to 4k minus 8. Now what would I do?
You add like terms.
I kind of. We're going to call it something different, but we're going to get our like terms together, right? So we want to get our k's together, right? So would you rather subtract 2k or subtract 4k, Abby?
Subtract 2k.
Subtract 2k. Okay, let's subtract 2k. Keep them positive.
Go Abby.
2 is greater than or equal to 2k minus 8. So now what do we have to do since we subtracted 2k?
Wait a minute.
We want to add 8. Why do we want to add 8 instead of subtracting 2?
You want to get that because you can't because there's nothing on that side.
Yeah.
Because then there'd be nothing on the side. We want to get everything away from our variables.
Wait, so 10.
So we'd add 8 to both sides, and you get
Wait a minute.
10 is greater than or equal to 2k.
Oh, wait.
So now we divide by 2, right?
Look at that. I did it.
And you get 5 is greater than or equal to k. That make sense?
Yes. Wait, did you have to flip it too?
Then we do have to flip it.
Oh.
K is less than or equal to 5. Let's make a graph.
Wait, where did we flip the sign?
Great question. Where do we flip the sign? We flip the sign here at the end when we had to flip the order.
Why?
Where did you We didn't end up dividing by a negative. We divided by a positive, so we didn't have to flip it. Now, if you were to have subtracted 4k from both sides, then you would have to divide by a negative at the end and flip the sign. I'll look at it in a second, okay? But don't rewrite it yet. I want to see it. So we have 4, 5, 6. Close circle at 5. Going which direction?
This way.
Okay, it's going to the left. Very good, very good. And our set notation with our brace, k such that k is less than or equal to 5.
That was good.
All right, thanks, guys, thanks. Okay. Okay. Oh, I just realized I wasn't recording any of this. Okay. We talked about on number 4 here. We talked about how to graph the fraction here. So we graph the fraction. Now, if you want, you can do whole numbers. Okay, like we did on the homework. Or you can do negative 5 over 2 and say this is negative 3 and this is negative 2. Either way. Open circle and going to the right. Okay, Ellie, you said you're confused. Where did I lose you? In the green or in the orange?
Like, okay, wait, so you take 20 and then like divide it by -8.
Yep.
And then is that a fraction because 8 doesn't go into 20.
Yep, exactly.
And then it was a half moon.
Does that make sense, Ellie, or are you still confused?
I'm still confused.
Okay, so to recap the entire problem, we combine like terms, negative 6 and 20, you get 14. Then we added 6 to both sides. There were multiple math moves we could have done in this step. We chose to add 6 on both sides. 14 plus 6 is 20. X plus 20 is greater than negative 7x. Now we need our x's together away from our constant, so we subtract x. 20 is greater than negative 8x. So we divide by negative 8 to get rid of this multiplication. 8 doesn't go into 20 evenly, so we're going to be left with a fraction still. We're okay with fractions. We say 20 over 8 reduces to 5 over 2, or negative 5 over 2, because 4 goes into both 20 and 8. So we have negative 5 over 2 is now less than x. It's less than instead of greater than because we divided by a negative on both sides, so we had to flip the sign. Then we have to flip the inequality back over because we want the variable on the left. And so when we flip it back over the other direction, we have to flip the sign one more time from less than to greater than negative 5 over 2. So we flipped them twice, but for different reasons. So we can't just ignore the flipping. We have to flip it each time because they're for different reasons. Okay, Courtney?
How is 5 over 2 between 3 and 2?
So yeah, negative 5 over 2 is negative 2.5. So like if you think like negative 3, if you were to make that into a fraction, into halves, 3 is 6 halves, and 2 is 4 halves. And so 5 is between 6 and 4. Yep, great question. Ellie, did that clear things up for you or no? Yeah, kind of. Okay, well, if we have more questions on it later, don't hesitate to ask, okay? I want to help. Recap on 5 again. Okay, we had to do the multiplication by 6 first and then go through our SADMEP. On 6, we'd end up having to multiply by a reciprocal, wouldn't we?
Yes.
Okay, but we know how to do that, don't we? Okay, you guys are comfortable skipping that for now?
Yeah.
Okay, we'll skip it for now.
For which one?
Number 6. And we'll go on to number 7. Okay? So, how would we do number 7? Distribute. Okay, who can help me with that distributing right now? Okay? Haven, go ahead. 2 times x is?
2x.
Yep. Plus.
Is plus 2.
Yep. And Haven, do you want to do the other side too?
Sure.
I'll go ahead.
2x.
Yep.
And minus 4.
Nailed it. 2x plus 2 is less than 2x minus 4. Okay? Jaden.
This has no solution.
Ooh, I love it. I love it. Love it. Let's continue on and let's see, okay? Jaden's asking, does this have no solution, okay? Jaden, why are you thinking that right now?
Because there's 2x on both sides.
Okay, we're saying the same variable on both sides with the same signs. We've seen this kind of stuff before, and we've seen it either be no solution or all real or infinitely many solutions. So we'll see which one this is, or if it is one. Okay, so what could we do next?
Add 4.
Okay, you could add 4.
Get rid of the. Get rid of the x.
Does it matter
Okay.
what order you do it?
It doesn't matter what order you're doing. That's a great question.
We should do the x
Forgot.
Yeah, you could do the x's first if you want. Oh, I did forget it. Thank you. So it's 2x plus 6 is less than 2x since we added 4. So now we'd want to get our x's together, right? How would you do that? 6 is greater than, what's 2x minus 2x?
Oh, x.
No.
0.
0. Anything minus itself is 0. Is 6 greater than 0? Nope. So this is no solution. Okay. Now let's see. If we had done something different in this step, guys, and we had done this, 2x plus 2 is less than 2x minus 4. And let's say we subtracted 2x right away. We'd have 2 is less than negative 4. And we'd ask ourselves the same question. Is 2 less than negative 4? No. And so just like we have not equal, we have not less than, and you still get no solution because that is not true. We have no variables left, and it's a non-true inequality. Now what would happen if it was a true inequality?
Then it'd be IMS.
It would be IMS. Yeah, if it was a true inequality, like it was 0 less than 2, well, we say, oh, that's true. Courtney.
For that, then would you just put no solution? You don't have to do any brackets or anything like that?
Correct. You just no solution. Yep. The only time we do braces or anything like that or the graphing is when we have a solution. Here, we don't have any, so we don't have to do anything. Great question. Any other questions? Alrighty. On 8, write and solve this inequality. 3 times the number minus 18 is at least 5 times the number plus 22. I want you guys to try that. Try writing it. So who wants to help me out with what my equation or my inequality would be here, okay? Alice, you want to help me out on it?
No. 3x minus 18 is equal to or more than, is that
Greater than or equal to?
5 times x plus 22.
That's exactly correct. Great job, Alice. Slap on the back there, okay? 3x minus 18 is greater than or equal to 5x plus 22. Now, why do we have to use x on the right side like we did the left side?
Because it's...
Here it says 3 times a number, and then it says 5 times the number. That means we're talking about the same number, the same variable.
What would it be if it didn't? Would it be another number?
Yep, if it just said another number, then we'd have to choose a different variable. Yep, Abby, what was your question? Okay, any questions on that? Could we go through and solve this and graph it and do all that? Yeah, I'm not going to make you right now, but we could. Okay. I have these out of order. I'm sorry about that. I have 11 before 9 and 10, but this is actually number 9. I just needed to reorder it. Whoopsie. Keith's dog weighs 90 pounds. Keith has a dog, okay? Doggo, 90 pounds. The veterinarian told him that a healthy weight for his dog would be less than 75 pounds. Keith's a little fat, okay? Keith's the chubby doggo. If Keith's doggo can lose an average of 1.25 pounds per week on a certain diet, how long will it take to reach a healthy weight? Okay, well, what's our key information here? We always like to highlight key information. What's a piece of key information? Brady, what's something that's key?
90 pounds.
90 pounds. That's what he's currently at, okay? Haven, what else is key?
Loses an average of 1.5.
Okay, he can lose an average of 1.25 pounds per week, okay? What's another piece of key information, Elijah?
75 pounds.
He's currently 75 pounds, okay? And then what's another key piece of information, okay, Courtney?
Less than 75 pounds.
Okay, it says we want to be less than 75 pounds. So specifically, we want to be less than 75 pounds, okay? Anything else that's key, we think? Okay. So we're trying to figure out how long, so we're trying to figure out how many weeks, okay? So what do we think our variable is going to be? We always have a variable. What do we think our variable is going to be? Okay, Alice. Okay, W for weeks. Okay, we don't care what we call it, but it is 4 weeks. Okay, so we can do W for weeks. Okay, does that make sense? Okay, so we're going to have a variable in here somewhere. Now, can somebody help me try and set this one up? Okay, Abby, you want to take a risk?
Good. So you need to do 90 minus 75 to figure out how much weight.
Okay, so that's one way you can do it. That's one way you can do it. You can say 90 minus 75. That's almost ignoring, though, our less than 75 pounds here, okay? So what you're saying could work, and I'll maybe come back to you in a bit, okay? And we'll compare why that one would work too, okay? Courtney, what are you thinking?
90 minus 1.25 times W is greater than 75.
Okay? And I'm actually going to slightly disagree with this. Can anyone tell me what I slightly disagree with this on? The greater than. What symbol does it say we have?
Less.
It's less than 75. So we need the dog to be less than 75. Okay? So we want the dog to be less than that for the healthy weight. That's what the vet said. So this would be our setup. The doggo starts at 90 pounds. It can lose or subtract 1.25 pounds per week. So after 2 weeks, it's 2.5. 3 weeks, 3.75. 4 weeks, 5 pounds. And we want to get this doggo less than 75. Okay? Well, how would we, or excuse me, do we have any questions on why this is a setup? Okay. So, how do we solve? Jaden? Subtract 90. I'll go with the raised hand there. Sorry, Abby. So 90 minus 90 is 0. Negative 1.25W is less than negative 15. Now what would we do? Okay, Alice?
You divide 1.25 on both sides.
Yeah, divide by negative 1.25 on both sides. Now we're dividing by a negative, so what's going to happen with our inequality? It's going to flip, right? And we're going to end up getting a positive answer because we have a negative divided by a negative, which makes sense because you can't have negative time. You're going to have positive weeks. Now 15 divided by 1.25, we don't know that off the top of our head, do we? So let's do that off to the side. Now, can we have a decimal outside the division? So we need to move that how many spots? So how many spots do we need to move this decimal? And I'll put it up here, okay? And call it 1,500. So does 125 go into 1? Does it go into 15? Does it go into 150? Yeah. How many times? Once. And it is 125. Subtract it, you get 25, or 250. How many times does 125 go into 250? Twice. And it is exactly 250. So W is greater than 12. So how long will it take his dog to reach a healthy weight? Okay, more than 12 weeks.
Goodness gracious.
It's going to take a while.
But what if he goes on a run every single day?
Oh, then that can increase it, right? Okay. So it's going to take more than 12 weeks for this dog to lose enough.
I wonder what that would be.
You wonder what that would be? What?
I wonder that would be
Like the running and like if you burn like extra calories and stuff like that. Yeah. Like that's an interesting conversation to have because it could have a lot of different other variables in here. Right now we're just talking about one variable, but there could be so many more. Now, Abby, your equation you were going to say earlier, you're going to do 90 minus 75 and say that that has to be, that would have to be greater than, or excuse me, less than the 1.25 pounds he can lose per week. And saying the dog would need to lose 15 pounds. And they're going to take they need to lose more than 15 pounds. So 15 pounds is less than what they need to lose at 1.25 pounds per week. So we'd end up having the same division problem. 15 divided by 1.25, which we said was 12. So we'd have 12 is less than W. Flip it around, you get the same thing. So it can still work.
Good job, Abby.
Okay? Yes?
I'm reading after the class and then
Okay.
I was wondering if I could get the match on
Yes. Okay.
Papa.
I actually want you guys to work on number 9 right now. So go ahead and start working on number 9, please. Okay, let's talk about this one up here, okay, first. Okay, maybe. So, we distribute, what's negative 7 times 6? Or times S?
Negative 7S.
Yeah, and what's negative 7 times 4? Negative 28. Plus 11S is greater than or equal to, don't forget that isn't or equal to, it's kind of barely there. But it's greater than or equal to 8S, as I complete that 8, minus 4S minus 2, because we have to take this negative with the 2 and distribute that. Okay? Questions on that first step? Okay.
Add negative, right?
What was that?
Subtracting a number is the same as adding a negative.
Yep, subtracting a number, same thing as adding the opposite of what's there.
Combine
Yeah.
like terms.
Combine like terms. Negative 7S plus 11S makes what? 4S. 4S minus 28 is greater than or equal to, what's 8S minus 4S? 4S minus 2.
Yeah, where did that come from?
solution.
It's
Okay.
not equal to.
So it has this little one here. It's barely there. It printed wrong. Okay? This one that's barely there. It kind of formatted and printed wrong there. So it is or equal to. So it heads up there. And yep, Jaden, you're on to something again here, okay? So 4S minus 28 is greater than or equal to 4S minus 2. Well, let's go ahead and subtract these 4S's so we can see more clearly what's happening here. Negative 28 is greater than or equal to negative 2. Is negative 28 greater than or equal to negative 2?
I mean, if you do math or mathematics,
No, it smells like cap. Okay? There is no solution.
Wait, come look at what I did. Because that's what I got.
Okay. So, yep. So you would subtract 4S, not divide by 4. Because you saw the 4S being added with 30. And then you'll get 0 is greater than or equal.
So I take 4S from here,
Yep, you subtract it.
and so that would be 0.
Yep.
And then, but if I take it from here,
Yep. You just have 30 left, right?
yeah.
Yep. Oh, sorry. Yes, Brady. Thank you for telling me.
I did it a different way.
Okay, what'd you do?
Well, I didn't get the answer though,
I just think the answer.
Okay.
this is what
Is your first step the same?
no, I did plus 7 and did negative
Ah.
4 plus 7.
Okay, so we have to distribute first here.
Yeah, that's what I did.
Okay, so this is the same as mine?
Yeah, it is.
Okay, but this is different.
Yeah.
So you added 7,
To negative 4.
and you got plus 3S?
Yeah.
Okay. And then what'd you do?
And then I did negative 11S.
Okay.
And negative. No, I did. Yeah.
You subtracted 11S, and then you got what?
2 plus 3. Negative.
Negative 3S plus 3S?
Negative 11S. I think that.
Okay. Yep. So what's 8s minus 8s?
0.
0. So when you get negative 28 is greater than or equal to negative 2?
Yeah.
Yeah, so you got the same thing. Yep. Great question. Okay. Let's talk about this next one up here, our last one up here. So I would go through and distribute. And what do I have to be careful of with this this 3? It's a negative. If we need to actually change this to a negative, we will change this to adding a negative to help us out. So 18, totally. What's negative 3 times 8c? Negative 24. C. Okay, negative 3 times 4?
That's put in 24.
What?
25.
Okay, what's negative 3 times c? Negative 12. Is greater than or equal to. This is another or equal to that didn't print well. Everyone know this. This is another or equal to that didn't print well. Negative 6 times 4c is negative 24c again, haha. And negative 6 times negative 1 is positive 6.
You know what's put in 24?
What?
25.
Woo. Yep.
You're 25 in one day.
What?
You're 25 in one day.
I'm 25 in 2 days.
I forgot I should not.
Okay. Combine like terms. 18 minus 12. 18 and a negative 12 combined to be?
37.
Try it again. 18 and a negative 12. 6. 6 minus 24c, we don't care about the order, is greater than or equal to negative 24c plus 6.
Wait. So close.
Oh, wait, no.
What are we noticing?
That's the same thing.
Are these the same thing on both sides? Okay.
Yes, it is.
Okay, they're in different order. Okay, so we might be inclined to think IMS. Now, if this since this is an or equal to, it is going to be an IMS. But what if it wasn't? What if it was just is greater than? Would that be true anymore?
Then you would have to go all the way to the finish.
Then we need to go all the way to the finish. Okay, let's go all the way to the finish anyway. Let's see what happens. We add 24c. 6 is greater than or equal to 6. Is 6 greater than or equal to 6? Yeah, so it is IMS. Now, if it had said, instead of or equal to, if it had just said 6 is greater than 6, what would that be?
No solution.
That'd be no solution because that's not true. But it is or equal to. So it is infinitely many solutions because it is always true. Okay, yes, Brady.
I also did it a different way.
Okay, did you end up getting the same thing?
No.
Okay, so Brady, did you end up adding 24c here? Or excuse me,
Well, I
did
got the first part right, but the second.
you get this same thing I have here or no? Okay, did you subtract 18 or add 12?
No, I add 12 to 6.
Yep, so you added 12 and you got 18 over here, right?
Yeah.
Okay, and then, so that'll end up being the same thing, Brady. Once you add 12 there, you'd end up getting the same thing because you're still combining everything. So you'd have, yep, so you'd have 18. So you have 18 minus 24c, and you have a negative 24c plus 18. So if you were to subtract 24, add 24c, you get 18 is greater than or equal to 18. Is that true?
Yeah.
So you still get IMS. You just had some things moved around differently. Okay. Now, guys, heads up. We are going to be taking a quiz next class over 3-1 through 3-3. Over 3-1 through 3-3, we are going to be taking a quiz next class, okay? The homework I'm going to pass out today is a review over 3-1 through 3-3. So we have some of our stuff that we did for today, the 3-1, 3-2, one-step equations, one-step inequalities. We also have 3.3 today on it, which is the multi-step. Yes?